Welcome to Crack It. In this video, we are going to discuss a very important topic, which is a frequently asked interview question, which is nothing but how to achieve asynchronous programming using Spring Boot application. How is asynchronous property achieved in Java? What are the benefits of using @async annotation? What are the benefits of using @enable async annotation? How are they working? So we are going to see all these with a live code demo, and along with that we are going to discuss the interview questions that is associated with this asynchronous programming topic. So let's start the discussion. Before we deep dive into how @async annotation works or @enable async annotation works, let's try to understand what asynchronous processing is. I'll try to just give a gist of it. So why do we need asynchronous processing? So let's try to understand both of these first. So there's an application and I want to boost that application's performance, then asynchronous processing is a real boon to the developers. How? If suppose there's no asynchronous processing in place, then what we will do, we will run all our requests synchronously. If suppose a web request, a client sends a request, what will happen? That request will sequentially process everything. Suppose say a client sends a request to the microservice M1 and it needs to call microservice M2, M3 and M4 for its it needs to get the response and it needs to process the response from all the three microservices and it needs to send it back. But the call, let's assume the call to M2, M3 and M4 are independent. These three can happen asynchronously or independently. But in the previous or the traditional way, if it is happening synchronously, then the call to M2 has to wait until M1 finishes. Similarly, the call to M3 should wait until M2 finishes. Even though they are not related, but they has to wait until the previous request completes. So this will affect my application's performance. So what do I need to do? Then there comes something called as asynchronous processing. I need to scale my application, like my application is scaling really well and I demand a quicker response time. I don't want my application to take a long time. Then the synchronous is absolutely an issue. Then what do we need to do? Then asynchronous processing is a solution. What can we do in the example that I have given? So M1, the call to M1 should be asynchronous. The call to M2 will be asynchronous. The call to M3 will be asynchronous. So all these three will happen asynchronously, and then we can process the response from all three and we can send it back to the client. This will save a huge time. So we are going to see an example similar to this, wherein we are going to call three different APIs asynchronously to understand how this asynchronous processing works and how can we use this @async and @enable async in our Spring Boot application. We are now going to write a service which is going to asynchronously call three APIs of a microservice. So we are going to start writing our code. So before writing our code, we need to know what are the steps that is involved in writing the asynchronous processing. So let me first explain the steps, then let's go write the code. First, we need to know what @async is. @async is an annotation and that we will use it on top of the methods to indicate that this method is going to execute asynchronously, that is in a separate thread. If suppose I am calling a method that is annotated with @async, it will run in a separate thread. It will not run in the main thread. It will let the main thread do the next work that is queued and it will run in a separate thread. So here comes the asynchronous processing. It will free the main thread to continue its operation. So the @async annotation, which will be applied to the methods to indicate that that method will be executed asynchronously. That is on a separate thread, not the main thread. So when the method annotated with this async annotation is invoked, it's executed in a separate thread, allowing the caller to continue with its operations. Since it is not blocking the main thread, it will allow the caller to continue its operation. This is the main purpose of @async annotation. Next is @enable async annotation. So if at async annotation needs to work in our application, then we need to use at enable async either in the configuration class or in our Spring Boot application class. So if my async needs to work in my application, then I need at enable in async. So where do I need to use this at enable async? I can use it on a class along with at configuration annotation, or I can use it in my main class where I have at Spring Boot configuration annotation. So while at async marks method to be executed asynchronously, it requires some configuration to work. And what are those configurations? This is where this at enable async comes into play. This annotation when added to the configuration class. So I've said this can be added in two places, either in the at configuration annotation, either as a separate class, or in the at Spring Boot application main class. So it will signal to look for the methods marked with at async and proxy them to be executed asynchronously. It's simple. Why do I need at enable async? I want at async to work in my application. So for that I need at enable async. What will this at enable async do? It will scan for the class, it will scan the classes, and it will identify the methods that is annotated with async, and it will create proxy for them to execute asynchronously. Straightforward. Next is executor configuration. So we can configure thread pool executors in our application. By default, if we didn't configure anything, Spring uses simple async task executor. This we can use for local, but however for production scenarios, it's always recommended to configure a custom task executor. Anyways, I'll explain you when I will explain the interview questions on how we can configure the thread pool executor, but it's always recommended to create a thread pool executor for yourself in a production scenarios, not to use Spring's simple async task executor. Next comes the exception handling. Exception handling is little tricky in the asynchronous code. So if you didn't handle it properly, you are lost. You will not be able to identify that the caller is broken. So you will not be able to identify it. So if you are using at async in your application, you need to make sure that you are overriding get async and caught exception handler method. If not, you're lost. Your exception will be lost and you will not be able to identify where your application failed. Anyways, we are going to write coding for all these except for executor configuration. Since I am using it in local, I am not showing this. If you want example for this executor configuration as well, please let me know in the comment section. I'll cover as a separate video, but even then I will explain this executor configuration while explaining the interview questions followed by the demo. Let's start the coding now. To demo how at async annotation works, or at enable async annotation works, or how asynchronous processing happens in the Spring Boot applications, I have created a Spring Boot application and I have named it as Employee Service Async Demo. So in this application, I don't have any code related to the business logic. This microservice is a straightforward wherein I have a controller class, and if you see here, I have annotated with at rest controller and I have provided the mapping for this class, and I have written 3 APIs in my controller. One is for the addresses, another is for the phone numbers, and the other is for the names. And these 3 APIs are returning a simple string. So we don't have any business logic in it. But why do we need this microservice? Because I am going to call this service or this Spring Boot application from another Spring Boot application to demo how at async works. So what will I do? While calling this specific API, I will add at async to that method. So this microservice is very simple and straightforward. We don't have any business logic. We have just written it to illustrate how at async works. Anyways, I'll push this code in the GitHub repository. You can go verify it whenever you want. This is the code that I have created for the async demo. Let's go through the code and let's try to understand what is here. So before that, let's recall what are the 4 steps that we read just now. It's nothing but we need to use at enable async in our application. We need to enable at async in our application. we need to have executor configurations and we need to have exception handlings. As we know, executor configurations is only for the production code. I didn't add it here. So we have 3 steps. We did 3 steps in this code. I'll explain one by one clearly. So this is my main class and I have named it as async demo application. I'll come to this why I have given at enable fiend clients later. I'll come to that later. So I'll go to my controller and I'll show you what I have. So controller, it's like very simple. I have a get mapping for the controller and I'm trying to call some methods here. Let's come to it one by one. I'll first go check whether I have at async in my application or not. So yes, sorry, I've commented this code. I'll uncomment it. Yes, if you see here, I have at enable async in my application. So I have written my configuration class separately. So at enable async should always either work with at configuration annotation, or here I have to go and add at enable async. Since I have a separate class, I have added it here. We need to have this at configuration annotation to make at enable async to work, or else it will not work. This is the first thing we need to understand. So this I have written it for the exception handling. I'll come to this part later. So what is the first step? First step is I need to have at enable async in my application, and at enable async will work along with at configuration. Do I have it? Yes, I have it. Next, what is that? I need to write async methods which are going to execute asynchronously using the at async annotation. So if you see here, I have a service class. I have annotated with at service. I have a service class, and in this service class I have 3 methods, and these 3 methods are annotated with at async annotation. So for this at async to work, I need to have at enable async, and I have it already. So what I am doing? So I am calling what I am doing in this at async, inside this at async method. So I am calling employee fiend client dot get addresses of. So this is nothing but I am calling the microservice which I just showed, nothing but the employee microservice from my async demo application. So I am making those 3 API calls asynchronous in this piece of code. So all the 3 calls to those APIs will execute asynchronously. Why it will execute asynchronously? Because I have added at async annotation during that call. So if you do not know about fiend client, or if you have any doubts in the fiend client, we have already covered a separate video for the fiend client. I'll provide the link here. You can go check that first. So this fiend client I have written to call the another microservice, which is nothing but the employee microservice. If you prefer working with REST templates, yes, it's your wish. You can write the code to call the other microservice using REST templates as well. For my convenience, I'm using fiend client. So what do we need to provide? Fiend client. In this fiend client should be an interface. Yes, this is an interface, and I need to provide the URL of the caller API. This is the URL of the caller API, and these are the 3 APIs that I am going to call. This is my employee microservice, and these are the 3 APIs. Yes, my path is correct. I have provided it correctly in my fiend client, and I have provided at get mapping of /addresses, phone numbers and names. Everything is correct. Just to cross verify and to make sure everything is correct, I have opened this microservice. So our fiend client is ready. We are all set to call the another microservice. I want to let's go back to our async demo application, and since my fiend client need to work in my application, I need to have this at enable fiend clients annotation. That's the reason I have added at enable fiend clients. Since I'm using fiend client to call another microservice, I need to have this annotation. That's the reason we are using it here. So let me go through the code from the controller now. So I have a controller, and in the controller we have I've created a async service as well. So what am I doing? I'm calling 3 calls. One is to fetch the employee names, another is to fetch the get employee addresses, another one is to fetch the employee phone numbers. Next, what I'm doing, I'll come to this completable futures after I explain what is there in the service. Let's go to the service, and in this service I'm using the Fiend client to call the to fetch the employee information from the another API that is existing in a different port. So that's lying somewhere else. So to access that API, I'm using this Fiend client. So to access those API, what I'm doing, I'm using @async in my code. So from the controller, if we use these 3 services, the moment it comes here, this will get a separate thread. It will free the main thread. So if my control comes here, if suppose if my control comes here, main thread comes here to the line 24, and it goes to this method to fetch the employee names, another one thread will get created just to execute this, and my main thread will get freed. It will not wait for the employee names to finish. The line number 29 will not wait for the line number 24 to finish. Why? This has a separate thread. The same will happen for employee addresses as well. This will also execute asynchronously since we have added this @async annotation. So my main thread will get freed the moment it went inside this method. So these 3 will execute parallelly or asynchronously. This line number 25 will not wait for line number 24 to get finished. That's the point here. So that is why we are using @asynchronous to improve our performance in my application. So all these 3 will call the API, fetch the information, and then it will return the response to the controller. So if we are using @async, or if we are in the asynchronous processing, it's always good to use the completable futures. So if there is something happening asynchronously, then I need to return that as a completable future, and that's why I'm using completable future dot completed feature of what is the response that I am getting from this API call. So similarly, likewise, I have did the same for the phone numbers and the employee names. If suppose we are not returning in completable futures or futures, whichever you want, we will not be able to handle the exceptions. So if I'm just returning phone numbers, what will happen? Yes, the response will still go, but handling exception is really difficult. Even if this throws some exception, the API throws some exception, what will happen? I will not be able to handle that exception at all. So we need to use either completable futures or futures. Always recommended to use completable futures. And also please let me know in the comment section if you want a separate video for the completable futures. Absolutely, we will cover a separate video for it. But the main motto for this video is to use @async and using the purpose of @async and @enable async annotation. So that's why I'm not going deep dive into the completable future and the other methods that we have in the completable future. So if you want, let me know in the comment section. I'll cover it as a separate video. So these 3 will execute asynchronously. So that is what I have in my service. I don't have anything fancy. I'm just calling my microservice, which is nothing but the employee microservice, using the Fiend client implementation. And to call all the 3 APIs in my microservice, employee microservice, I'm using this @async annotation. Let me go to the controller now. Yeah, since it is returning completable future, we are having completable future of string. So I'm getting all these 3. And what is this all of? We can use this all of if I want all these to be done. Only after all this is done, the control will go to line number 30, which means wait until all these 3 are finished. All these 3 executions are finished. That is what is called as completable dot all of. You can read the description that is provided here, but that is what it is. It will wait until all these 3 to finish, and then only it will go to the control will go to the line number 30. And this join, this is to return the result when complete. That is why we are using this join. If you see here, returns the result value when complete, or throws an exception if it is completed exceptionally. If there is an exception, it will throw the exception. If it finished successfully, it will return me the result. That is why we are using join. This is like in multi-threading we will use join, right? This join is same like that. So each of these is running in a separate thread, and to fetch the result from those, what do we need to do? We need to use this join method. All of, if you see here, all of is to wait until all these are done. So this is done. Then what I'm doing, I'm like, this code is like straightforward. I'm adding all these 3 strings in a list and I am returning it. So let me do one thing. I'll start this application. I'll start the employee application as well. So both the application is started. Let's go to the postman and let's see what happens. So I forgot to say you that I have added server port as 8081 here. I'll show you that as well. No, not here, sorry. In my async demo, I have added 8081 because this employee service application is running in 8080. So I have changed this to 8081, else we will get conflicts. So I have added it like this. So if you see here, I'm trying to call the controller and I'm able to fetch the response. I want to show you one more thing to you guys. Just a minute. Let's come here and let's see the logs. So start employee names, get employee address, get employee phone numbers, all come immediately. So if it is asynchronous, you know that. Let me open that file. Where is it? Async service. So if it is synchronous, start end, that should be the sequence. But now if you see the sequence, all 3 got started and then all 3 got completed, and you can see that this is not executing in the main threads. If you see here, everything is executing in the main thread, right? Each one has a different thread. This is started in task 1, this is started in task 2, task 3 and each got finished separately. These 3 are not running in the main thread. These 3 has started separately. This also I want to show. This is the main demo for the asynchronous processing. I hope you all understand. If you have any questions in this demo, please let me know in the comment section. Like the content, if you understand what at enable async is, what at async is, please like the video. It will help others to refer this video. Your likes means a lot. Please like the video if you like the content. So next step is the third step, which is nothing but the exception handling. So for the exception handling, what do we need to do is, there is something called async configurer support. So we need to extend that async configurer support in our configuration file. So we need to create a async configuration file and we need to extend at async configurer support. If we extend this, it will ask us to override a method, and that method is nothing but the exception handler for the uncaught exceptions, async uncaught exception handler. So it will ask us to override that method, and I have overridden that method, and I am returning some I have written a separate exception handler. So I'm creating I'm giving us a return new async exception handler. So if you see here, I am implementing something called async uncaught exception handler here. So what is the step for writing the exceptions? We need to have a configuration class, and in our configuration class we need to extend async configurer support. Sorry. If we do that, it will ask us to override a method which is nothing but it will ask us to write a exception handler for our application. So we need to write a separate exception handler for our application. Also we need to implement async uncaught exception handler. This exception handler helps us to handle all the uncaught exceptions that is happening in the asynchronous processing. So we need to implement that. So if we implement it will ask us to write a method which is nothing but the handle and caught exceptions. I'm not doing anything here, I'm just logging the exception if it is happening. So our third step is also completed. Next and final step is thread pool executors. I didn't write thread pool executors, but I'm going to explain it in few minutes when I am discussing the interview questions. So we know what at enable asynchronous, we know what at asynchronous, we know how to handle exceptions in our asynchronous processing. We know everything. So let's go start the interview questions now. So this is our first interview question. It's very easy. What is the use of at enable async annotation? So we know at enable async is to signal the Spring framework to look for the methods that is annotated with at async annotation. So if we want our Spring framework to execute asynchronously, we need to have this at enable async annotation. So where do we need to add this annotation? We can add this annotation in two of the places, either in a separate class along with at configuration annotation, or in the main class method along with at Spring Boot application annotation. We have two options. It is completely our choice where we can use this annotation. This annotation will also create a proxy for the methods that are annotated with at async to be executed asynchronously, which is nothing but it will create a separate threads for those methods that are annotated with at async. What is the limitation of async method? Can we have this async method and the caller in the same class? So let's assume this service, which is nothing but the cracked service, and if you see here, this is a fetch employee address method, and this method in turn is calling this get employee address, which is annotated with at async. So can I have the caller and the at async method in the same class? No, the answer is no. It is very important that we should not call at async method within the same class. Why? Because as I told earlier, this annotation at enables async will create a proxy. So for this, due to this proxy based nature of Spring's AOP framework, if async method resides in the same class, it will not actually execute asynchronously. Why? This call will not go through the proxy. Why? Instead it will consider this as a direct method call. So we want this specific async method to be a proxy method too. We need this to execute it asynchronously. For this to happen, this should reside in a separate class. If it resides in the same class, what will happen? It will consider this as a direct method call and not as the asynchronous method call. So this is a very important limitation that we should be aware of. Also, there is a high chance that this will lead to an infinite loop, and this may cause the application to hang. So how do we need to rewrite this code? We need to rewrite this code by having this at async method in a separate class, and we need to call this from here. This is the way we need to write. So this is a limitation that we should aware of. This is one of the limitations of the at async keyword. What is the limitation of using async framework in a transactional methods? So I have a transactional method. Suppose say here's one here's something happening for the database operation 1, and something is happening for the database operation 2, and between that I have a async method, and that is going to perform another database operation which is nothing but database operation 3. So can I have this async method call inside a transactional method, inside a method which is annotated with at transactional? So first of all, what is at transactional? So if we use at transactional on top of a method or a class, which means that there is a transaction involved. So all these database operations are considered as a single unit of work. If one fails, nothing will happen. Like all the transactions which happened will get rolled back. If 2 fails, the database operation 1 which is completed will get rolled back. If 3 fails, that both the database operations 1 and 2 will get rolled back. So all these 3 will be a single unit of work. So if we use at async to make it asynchronous, it will run in the separate thread but not in the main thread. Yes, we know it will run it in a separate thread. So we cannot use it in the transaction context at all. Why? So if it should be transactional, then it should be in the same main thread to either roll back the operation if something happens or commit in a single unit. Since this piece of code will get executed in a separate thread and not the main thread, we cannot use @async annotation in the @transactional method call. If suppose we use it, then the database operation will not be in a consistent state. It will be in an inconsistent state. So is there any way that we can use? Yes, there is some other way called using a transactional template to manage the transaction out of the box, but Spring is not providing anything to support async inside the transaction. Out of the box, is there any option? Yes, there is an option. There is something called transaction template. We can use it, but we cannot, like, Spring is not providing anything out of the box. So if you want to know more about the transactional templates, please let me know in the comment section. I'll cover a separate video for it. That topic is huge. I'll cover a separate video for it. Limitation of @async annotation, which is nothing but why @async thread pools config has blocking issues. Is there any way to avoid it? If so, if yes, then how can we avoid it? So this is a very important interview question. You may be expected if you are asked to explain about asynchronous communication, because we are using asynchronous to avoid the blocking issues. But if our thread pools are not properly configured in our application, there is a high chance that the thread pools can be blocked and it will not serve the purpose of what we try to achieve. So I'll explain this through an example. Let's see this code. This is the thread pool executor that I have created, and if you see, I have defined the max pool size as 2 and I have defined the queue capacity as 500. Okay, at a time only 2 different asynchronous threads will run in my application. Why? Because I have defined my maximum thread pool size to be 2, and how many threads can be queued up? It is up to 500. So at any particular point of time, we will have maximum 2 async threads running. If more tasks coming in, what will happen? They will be queued up until the queue size reaches 500. Okay, the solution looks good, but there is a problem. What is the problem? If suppose assume one of our async tasks is taking too much time to execute or blocked because of an external dependency. So there is an external dependency and that is taking a lot of time, which will consume one of the threads most of the time. Okay, if that happens, what will happen? All the other tasks will be queued up and it will not be able to execute very fast. Why did we move to asynchronous? We moved to asynchronous because we want to perform our application much better. But if there is this problem which is blocking the thread to execute, then what will happen? This is an issue. We need to configure our thread pool task executor really well. So what is the solution? How do we need to solve it? If suppose we know a particular operation is going to take a much time, we need to assign that task with the separate thread pool executor. If you see in my application, I have configured 2 thread pools, and this is my primary and this is default, wherein I have set maximum pool size to 2 and 500. The same, I have created one more thread pool executor and I have set the pool size to 2 and queue to 500. Like code wise the both are same, but instead of me having only one thread pool executor, I have created 2 thread pools executor. And in the method, what will I do? Inside this asynchronous, I will provide this bean name. It is okay because I know this method is going to take much time and this will always take the threads from this thread pool and not from this. This will be free. All other operations, for all the default operations, the threads will be picked up from here. Only for those operations which I assume that will take time, I will assign that to this thread pool executor by providing that bean name inside this @async annotation. So my problem is solved. How is it solved? Yes, because for all the time consuming operations, the thread will be taken from this thread pool executor and this thread pool executor will always be available. So in this way, @async thread pools config blocking issue has been avoided. So even though at async is a fancy mechanism and it fancy mechanism, we need to be very careful while implementing at async annotation. Only if we know all the things which may lead to a problem, we need to write our code in a way that will not cause any of the problems which will totally suppress the purpose of asynchronous. So we have to be very, very careful. If you find this video informative, if you find this video helpful, please like the video and share it with your friends who are preparing for the interviews. Your likes and shares means a lot, and please comment it in the comment section if you want to describe any specific topics. So next interview question, how to handle exceptions while using asynchronous. We have seen this when we were creating the demo. So at async methods will not throw exceptions to the calling thread. We need to handle the exceptions properly within the at async method, or else they will be lost. Yes, as I told earlier during the demo, at async methods will not throw exceptions to the calling thread. So let's assume I have a method, I have a at async method, and in that I'm explicitly throwing exception, which is nothing but throw new exception of. Will this at async method will pass this exception to the caller? The answer is no, it will not do. So we have to handle the exceptions properly in when we use at async method. So but how can we achieve that? How can we handle that? So what we need to do is we need to provide the piece of code which we expect inside the try catch block, and the return type should be future. So by returning a future object and using a try catch block, we can properly handle the catch exceptions. This is one main point. So always, as I told earlier, to catch the exceptions, either we need to use future or we need to use completable future. We should not call directly like this, then our exception will get missed. There is a high chance that our exception will get missed. So so we need to return this as a future object, then only. And this async method call should be inside the try catch block, then only we will be able to catch the exception that is thrown by the async method. The problem is, if the async method does not return any value, then it's hard to find if any exception occurred while the method was executing. Yes, we are right. If this exception is missed, in this case, even though this is throwing exception, it will not come to this catch block. Why that exception will get missed? I will not, when there is an application failure and I am trying to debug, I will not be able to identify where exactly the application fails. So it's always important that we need to handle our exceptions really well, and that too, if we have async, we need to be very careful that the return type should be the future or the completable future, and we need to write those code inside the try catch block, and we need to handle the exception properly. And the very important point is we need to override the async uncaught exception handler. We need to write our own exception handler for this, and we need to override the at async uncaught exception handler. In this way, we can handle our exceptions. We clearly explained this in our demo. Thanks for watching Crack It. Please like, share, comment and subscribe for updates. If you want any specific topics to get discussed, please let us know in the comment section. We'll discuss it for sure. Also, please like the video. If you like the content, please share it with your friends who are preparing for interviews. Stay tuned for updates.